I welcome you all to today's lesson. This is the lesson which we want to do, speed time graph. So we are going to discuss through a lot of questions like you suggested yesterday that I need to make some more explanation on this. So I'm going to cover this today. So if you haven't subscribed to this YouTube channel, make sure you subscribe. This is my official channel. So let's make sure we subscribe, we hit the like button. So this is the question that we want to answer. It is saying, this is the first question. We are going to discuss through a lot of questions together. This is the way the question is saying, a sprinter runs a race of 200 meters. A total time for running the race is 25 seconds, ending at u meters per second. Below is a sketch of the motion of this person. So now, this is the graph, how the person was running. This is the graph. So we got the first question. So, like I've been telling you always, the first question is always simple. If you cannot get this one right, then you need to go through a lot of questions on this, because this one is under acceleration. So this one is very simple. This is very simple. So it's saying, calculate the acceleration in the first 4 seconds. You want to calculate the acceleration in the first 4 seconds. So how can you calculate the acceleration in the first 4 seconds? You need to know the formula that we get to use whenever we want to find the acceleration. So what's the formula? Just need to know this formula. The formula is this one. This is the formula for acceleration. Acceleration is equal to final velocity minus initial over time, like this. This is the formula for what? For acceleration. Where you are going to do this, this is now equal to, you say this is equal to, so in the first 4 seconds, it is where from here to there, this car was accelerating. So how can you calculate the acceleration now? So here where it started from rest, which is from 0, then increased its speed to 9 meters per second, which means that what you are going to do is that this is your what? This is your final speed, then this is your initial. So you are going to get the 9 there minus 0 where it started from, then you say over the time difference is 4. So just put a 4 here like this. Then finally you've got your answer. So what will be your answer now? Here you say 9 minus 0, it is 9, over what? Over 4. Then finally you've got your answer. So here when you divide there, what answer are you going to get? So this one into that one, what are we getting? 4 into 9, it is 2. So you say it is 2, remainder what? Remainder 1. Then 4 into 1, it can't. We put a point there, then we put a 0 there. So 4 into 10, it is 2, remainder 2. So 4 into 2, it can't. We put a 0, then we're going to have a 5. So then you say meters per second squared. So this is how you need to answer this first part. So this first part is always simple, like I've been telling you. It's very easy to find this one. Then we move to this part. So the next part is saying distance covered in the first 20 seconds. Distance covered in the first 20 seconds. So want to find the distance covered in the first 20 seconds. So when you look at this now, the distance which is covered in the first 20 seconds, it is here. Have you seen? From here to there. This is the distance which is covered in the first 20 seconds. So when you look at the shape here which is being formed, this is the shape of a what? Of a trapezium. So you need to know the formula of a trapezium now, where you say, so distance is equal to the formula for a trapezium. This is the formula for a trapezium. This is, hope we know this formula. This is the formula that we get to use. This is the formula for a trapezium. So with this formula of a trapezium, what we need to know is that we've got 2 sides which are parallel. So we've got a side from here to there. These sides are parallel, and this one. So the short one, it is A. So this is your A. Then this one here, from here to there. From here to there. This is the what? The B. Then this one here, it is the height. Have you seen? So I've been telling you that when you've got something like this, let's say you've got a shape like this one. So a shape can be in different ways. It can be like this. This is also a trapezium. It can be in different ways. It can be like this. Have you seen? It can be like this. This is also a trapezium. So it can be in different ways. So if it is in this manner like this, if it is like this, have you seen the way it is like this? So these two sides are parallel. So this is A, this is B. Then the height is here. But when it is pressed in this manner, when it is like this one here, it is the B, this is the A, then the height will be this one there. So these are some of the things that can help you recall the formulas to use and how to know the shapes. We are going to say distance is equal to, you say half like this, then you go to this. So what is your A? What is our A? From here to there, this is our A. So this difference here, what's the difference? 20 minus 4, it is 16. So you put your 16 there. You say plus. Plus what? You follow the same procedures that we are doing. Plus B from here to there. This is what? 20. So you say plus 20. Then what is your height? What is your height? From, this is your height. From this point to that point. Have you seen? This is from here to there. We get the readings from there. This is 9. So you get a 9 there. You put your 9 there. This is what you're going to do. So you continue with this. You say distance is equal to half like this. Then what is the answer there? You've got 36, then 9 there. So where you say this is equal to half of 36, it is what? Half of 36, it is 18. 18 times what? 18 times 9. Where you say distance now finally is equal to, so you say 18 times 9. What answer are you going to get? Definitely you are going to get 160 what? 162 meters. So this is your answer. So this was the distance covered. This was the distance covered in the first what? In the first 20 seconds. This is how you need to know this. This was the distance covered in the first 20 seconds. We've calculated. So from here to there, what we are forming, it is a trapezium. This is a trapezium. This is how a trapezium is. It is like this. So this whole thing here, it is called a what? A trapezium. So away from this now, I go to this question. This is now where a lot of people are finding some challenges. How to go about this one, how to work out this. So the question is saying, calculate the value of u. You just want to calculate the value of u. So how can you calculate the value of u? So it is very simple. I'm going to show you how you can calculate the value of u in an easy way. So where is u? Where is u? The u is where? This is where the u is. Here. This is where the u is. So you've seen that we've calculated the distance from here to there. So from this point to that point, we've calculated that the distance is what? Our distance is what? We've calculated that the distance is 162 meters. This is what we've calculated, 162. So 162, when the whole journey, it is 200. We were given in the question 200. So 162 is from here to there. What about this part? You just say 200 minus 162. What are you going to get? You are going to get what? 38. So we've got 38 this side. So this is 38 meters. Such that if we add these two, we come up with what? We come up with a 200, which is given in the question. This is how you are going to do. So now, how can you calculate the what? The value of u. So when you look at this shape that is being formed here, so you may wondering, or you may want to use the formula for acceleration. We don't need to use that because what we are given is a distance, which means that even us to calculate the value of u, we need to use the formula for the distance of the shape which is being formed. So the name of this shape is called a trapezium. So we are going to use a formula for trapezium to calculate the value of u. So this is a trapezium. So this short side here, it is called what? A. From here to there, this one is called B. To this one. Then this is H, where H is. Have you seen? This is where H is. So these are some of the things that you need to know and understand. So we need to get, we've got A here, we've got the B here. Then this is our height. The height is here. So this is the formula you are going to use. So what are you going to do? So I'm going to answer it here. I'm going to write it here, where we are going to say distance is equal to, like this. Then you say, this is what we are going to do. So say half A plus B H. Hope you are able to follow this. Hope you are able to understand. So you know the distance you are given for this one, the distance is what? 38. So you're going to say 38 is equal to like this. 38 is equal to what? You say half, open bracket. What is your A? From here to there, this is your A. So what is your A? U. So you put U plus. What is your B? What is your B? You check your B. B is from here to there. This is 9. So you put your 9 there. Then what is your height? The difference there, it is 5. Have you seen? This is what you are going to do. So here, this is a fraction. So to make things very easy, you just need to multiply this one by this 38. So 2 times 38, you get 76, which is equal to, here, this 2 has gone. We've remained with this bracket. So what we've remained with is u plus 9, like this, then a 5 outside. Then you start doing what? You start multiplying now. So you say 76 is equal to 5u. 5 times u, it is 5u, like this. Then you say plus what? 5 times 9, that is 45. This is what you are going to do. So with this now, then you do what? You group the like terms. This is what you're going to do. You group the what? You group the like terms. So what are we going to do? So this one will go to this other side. So we are going to say 76 minus 49. Obviously 76 minus the 45 that is there. This is what you're going to do. 76 minus what? Minus 45. The 45 that is there. What are you going to have? You're going to have what? 31. Which is equal to 5u. Like this. This is what you're going to do. Then you divide both sides by 5. You divide both sides by 5. Then 5 cancelled. Remain with u is equal to. So u is equal to what? 31 over 5. This is your answer. Have you seen the way I've answered? This is how you need to answer. So here I had to group right terms. So when this is positive, when it comes this side, it becomes minus. So it is 76 minus 45. This is what we need to do. This is what we need to get and understand. So we've answered the first question. This is our first question in this lesson. So you are able to see all the answers. This is how you need to work out this one. This is how you need to answer this one. So we've answered this. Let us move to the next part. So make sure you copy down this, you understand them properly. So we move to the other question. This is the other question. So this question is similar to what we've covered so far. It's similar to the other questions that we've covered. So it is saying the diagram below shows a speed-time graph of an object. It starts from rest and accelerates uniformly for 2 seconds. until it reaches a speed of 10 meters per second. It moves at this constant speed for 6 seconds, then accelerates until it reaches a speed v meters per second. After 5 seconds, finally it retardates for the next 8 seconds until it comes to rest, to a halt, like that. So this is what you need to get. So this part here, what they were trying to explain here, it is just the movement of this car. So they were just talking about the movement of this car that is here. This is what they were just talking about. So this is very simple. So what I'm going to do is this. You look at the questions which are given. This is the first thing you need to do. Look at the questions which are given. So as you can see, this first question is always simple because we've been doing this question. So it's saying acceleration during the first 2 seconds. So you calculate the acceleration during the first 2 seconds. It's very simple. I believe we are able to work out this one. So how do you calculate the acceleration? You know the formula that acceleration is equal to final velocity minus initial over time. Acceleration is equal to, you do this, then during the first 2 seconds, it is here, the first 2 seconds, it is there. So it started from rest here, from 0, it accelerated to that height which is 10. So 0 to 10. Have you seen? So the initial where it started from, it is 0. Then where it ended, that is a what? That is a 10. So final velocity, here this is your initial, this is your final. So your initial is what? 0, final 10. So just say 10 minus initial 0 over the time which is 2. We are able to work out this, I know. This is equal to 10 over 2. So 10 over 2, what is your answer? 10 over 2, what is your answer? So it is 5 meters per second squared. These are the units. Don't need to forget the units. So even if when you just forget to put this square here, then you are not talking about acceleration. You are talking about other things. So make sure you follow their specific SI units that we get to use. So I've got this other question here, which is saying the value V. So I calculate the value V if the retardation in the last 8 seconds is 3 meters per second squared. So I calculate the what? I calculate the value of V. I calculate the value of V if the retardation in the last 8 seconds is 3 meters per second squared. So how can I calculate the value of V? I go to my diagram. This is the sketch. So from here to there, I've been told that this car was retardating. Have you seen? So which means that the retardation there, here it is what? The acceleration is negative because it was retardating. This one, negative 3 meters per second. This is what we are going to do. This is what we are going to understand. So there, the retardation is 3. So which means the retardation is the negative of acceleration. So if we are to put A there, which means that is negative. This is what you need to get. So now, what are we given? We are given the retardation. So retardation is the opposite of, it is the negative of acceleration. Which means that the formula you are going to use is for that one, for what? Acceleration, because we are given acceleration. If we are given distance, which means we need to use that formula for distance. But in this case, we are given what? Acceleration. So we are going to use the formula for acceleration, where we are going to say acceleration is equal to final velocity minus initial over what? Over time. Since this one was retardating from this point to the other point, this is how it is going. So which means that what I'm going to do, this is what I'm going to do. So what is my final velocity there? I say acceleration is equal to my final velocity. So it was starting from here going to that point. So this is my initial velocity. This is my final velocity. So my final velocity is what? 0. minus where it was starting from. So it was starting at what? V there. The V. So I put minus V over. What is the time difference here? So what is your time difference? What is the time difference? So that is what? 21 and 13. So what will be your time difference? Your time difference, you say 21 minus 13, you get 8. So you put your 8 here. Have you seen? Where you are going to say that acceleration, you know acceleration. What is acceleration? Negative. It was retardating. So you put negative what? Negative 3, which is equal to 0 minus V, it is negative V, over what? Over 8, like this. This is what you are going to do. So there, where you put 1 here, then you cross multiply. So negative 3 times 8, it is negative what? 24, which is equal to negative V. Have you seen? So from here, you divide both sides by negative so that you cancel out that negative 1, even here negative 1. So negative cancelled, we've remained with a V, which is equal to negative cancelled, 1 into 24, it is 24. So that is your V. Your V is what? 24. This is how you need to calculate V. So we use the formula. So these are the formulas that we need to use. So if I've used the word retardation, which means that the answer here, I don't need to put a negative to show that it is retardation. No. Just the word retardation itself will tell you that this value is negative. But if I say acceleration was negative 2, which means that that was a what? A retardation. But for retardation, if I use the word retardation, just know that the answer will be positive, because I know that it is the what? The value which is negative. I've used the word retardation. So this is what we need to get and understand. So you've answered this question also. So you are just told to find the value of V. This is the V here, which is 24. Then we move to the other question. So what is this question saying? Average speed for the whole journey. We calculate the average speed for the whole journey. This whole journey now. So how do you calculate the average speed for this whole journey? So to make things very easy for you, where there is V there, you are going to put the what? You are going to put the actual value which is there. So the value there, it is 24. So you can put a 24 there so that you don't get confused, because you are going to use that one. So how many shapes are you able to see here? There is a triangle, a rectangle, trapezium, triangle. But this one here, you can remove a triangle here. Then you call this whole thing as what? You just call this whole thing here. You just call it as what? Trapezium. Have you seen? This is a trapezium. This is a trapezium. This is a triangle. So these are the formulas that you're going to use. We've got this one here. The first part here. This is a trapezium. So to find the distance here, you know that average speed is given by the formula where you say average speed is equal to total distance. Say total distance over time taken. So over time taken, this is what you are going to do, which is equal to, so this is equal to what? Total distance. What is your total distance? Total distance you don't have, but time you have. You know that time is 21. So you start now doing the calculations now, the shapes now. This is what you are going to follow. This is what we are going to do. This is what we are going to follow. So what I'm going to do on this one now is this. This is what I'm going to do. Say this one here, this is a trapezium. So I use the formula for what? For a trapezium. So what's the formula for trapezium? Half A plus B H, like this. So I say half like this, then I do this. So what is my A? These two sides which are what? Which are parallel to each other. So I've got a side here, also have a side there. So this short one from here to there, 2 and 8, this is the difference. So this is 6. 8 minus 2, 6. Plus, I'm going to put a plus there. Then what is my B from here to there? So which is 8. Then my height is this one here, which is what? 10. This is what I'm going to do. This is what you also need to do. So then, which is half like this, then here, when you add here, what are you going to get? You're going to get 14. 8 plus 6, 14, then a 10 there. Have you seen? Here, you continue, say 14 now. What is half of 14? 7. So just same as 7 times the 10 which is there, like this. So this one will give you what? 70. So the distance here for a trapezium here, it is what? 70 meters. Then you move to this one also, you move to this one. This is also what? A trapezium. So use the same formula. So this is what we are going to follow. So I use the same formula, you know, half, then I say A plus B, then H, like that. So I follow, I say half, then I say this is equal to what? What is my A here? So you check your A is here from there, which is 10. So you put a 10 there. You say plus, what is your B? From here to there. So you know the value there you've calculated, which is 24. So you're going to put a 24 there. You're going to do this. Then what is your height? The difference that is here. That is what? The difference. So the difference here, it is 5. So you put your 5 there. Then you just substitute half of what? When you add there, you get what? 34. Then a 5 there, of course, a 5 there. So that is a 5 that you're going to have. So this is now equal to, this is equal to what? This is equal to what? You say half of 34. This is what? 17. 17 times 5. What are you getting? 17 times 5. What are you getting? What is your answer? You're going to get what? 85. So confirm with this. Confirm with this one. 85. You get 85. So this is what I want you to get. You get what? 85. So this part here, we've got what? 85. This is the 85 that we're having. I move to this other one here. So for this other one here, this is very simple. This is what? A triangle. So I'm going to write it here. The formula for triangle is half BH. This is what I'm going to do. Half BH. So what is my B there? Base. This is my base. The difference there. Have you seen? You calculate the difference there. So we calculated this one. Hope you are still remembering. So this is what? 8. The difference. 21 minus 13, it is 8. Times the H, which is the height. 24. From here to there, that is 24. So half of 8. Here, 1, here, 4. So it is 4 times 24. What are you getting? 4 times what? 24. You're getting what? Here you're going to get 96 meters. So these are what we are having. We are having what? So you say we are having 70. I've calculated 70 there. 70 meters plus what? 85 plus 85 meters. Say plus what? Plus 96. What? 96 meters. What is your final answer there? So 96 plus 85 plus 70. What are you going to get? 251. So you're going to get 251 there. So put your 251 meters. This is the total distance. So this is how you need to calculate the total distance for the whole thing, for the whole journey. So it is what? Here we go back on our formula. So you say 251 meters over. Total time, it is 21. So finally, average speed is equal to what? Say average speed is equal to what? What is your average speed? So when you divide here, what will be your answer? So your answer will be 19.95. Have you seen? Like this. You're going to get 19 point what? 11.95. So you round off this answer, which will just be equal to what? 12 meters per second squared. This will be your answer. So just need to end here like this. But if you don't have a calculator, definitely calculators are not allowed. So you just leave it here. Have you seen? You just say The answer is what? 251 over 21 meters per second squared, because you can't manage 251 over 21, just say meters per second. You just leave it there. Have you seen? Because you cannot manage to divide this, so just leave that one as your answer. Have you seen? So these are what you need to follow. These are what you need to understand. Let us move to the next question now. The next question. Hope you are able to follow through. You are able to understand everything that I'm trying to do here. So let us move to the other question. We move to the next question. So this is the question that I'm going to end with. This is the question that we are going to end with. This is the question. So this is how the question is. So the question is saying the diagram below shows the speed time graph of two trains leaving a station at the same time. So these are leaving the station at the same time. Train A, so I'm just reading. Train A accelerates uniformly from rest to a speed of 50 meters per second in 4 seconds. It moves at this speed for 6 seconds before coming to rest in a further 2 seconds. Train B accelerates uniformly from rest to a speed of v meters per second in 6 seconds, then comes to rest in a further 6 seconds. This is the question which we are given. So they were just telling us about the movement of these two trains. So these were leaving the station at the same time. So what is the first question? What's the first question? So I look at this. What is the first question? What would be my first question? So you say the first question, this is the first question. Hope you are able to see. If you are not able to see, you can zoom your screen, like so that it can be in landscape, so that you'll be able to see clearly, because the words may be too small. So what you are going to do is this. Train, given that the trains moved the same distance, so these trains moved the same distance, calculate the maximum speed, which is v. You calculate the maximum, which is what? Which is v of train B. So this is the first question. This is the first question which I give you. So the key statement here is that given that the trains moved the same distance, so these moved the same what? They moved the same distance. They covered the same distance. These covered the same distance. So this is what happened. They covered the same distance. So they want you to calculate the value of u. So you now need to understand this question clearly and very well. So I want you to follow me properly even as I start explaining this thing. So it is moving that, given that the trains moved the same distance, calculate the maximum speed v of train B. So what you are going to do is that you are going to calculate the what? You are going to calculate the distance for this one here, which you are able to see. So you are able to see this one. So it started from here, there, went even there, then came back just like that. Have you seen? So now, what I'm going to tell you is this. The shape here which is being formed, it is a shape that is looking like this. A shape that is like this. It has moved like this, like this, like that. That is how the shape is. I don't know if you are able to see. This is how the shape is, like this. Moved here like this, even there like that. This is how the shape is. This is how that shape is. So now, how can you calculate the distance for this one? How can you calculate the distance? So the way in which you are going to use to calculate the distance is very simple. This is what we are going to do. So the formula here, when you see a shape like this, you can just use the one formula for trapezium. Say distance is equal to like this, a plus b then h. We just use one formula. You're just going to use one formula to calculate this. So now the formula you are going to use is this one. The formula here for what? For trapezium. We are going to do now, what is your A? This one on top here will be your A. This one here will be what? Your B. Then the distance there from there to there will be your height. So even a shape that looks like this, you need to use the formula for what? For a trapezium. These are the formulas that you need to use. Sorry about that. So you say distance is equal to half, like this. A, what is your A? From here to there. My interest is with train A. Here I'm just interested in train A, this train A. So train A, this is my A from here to there. The difference there is what? What's the difference there? What is your difference? 10 and 4, 6. Plus 10 minus 4, 6. Then what is your B? From there to there. This is 12. Say 12 here. Then what is your height? From here to there. The height is what? 50. So you put your 50 there. Put your 50, which is equal to, this is half of what? 18. Then we've got what here? We've got 50 there. So this is equal to, here you can say half of 18, this is 9. 9 times what? 9 times 50. Then the distance will be what? What will be your distance? You now look at that. What will be your distance? So that one is some kind of simple. So you are not supposed to use a calculator. Just say 9 times 5 there. What are you supposed to have? 45. So 45 and the 0 there. So 450. So meters. So this is the what? This is the distance for these trains. So they covered this distance. This is the distance which they covered. This is the distance they covered. So now, here what we are interested in is to find the value, the speed v. We find the v on this. So we've calculated the distance. So when you look at train B, let us now go to train B. So when you look at train B, when you look at this train, which is train B, what you have to do is that you are going to say from here to there. Have you seen the way this one is? Just these are two triangles. From here to there is 6. From here to there it is also 6. So here where it is being cut here, this part and this part are equal. So if they moved the same distance, which is 450, have you seen 450? So half was for this one, this part here. So train A here, this whole distance, when you move like this, you go there like that, it is what? 450. Even here, when you go there, you come back there, it is 450. But since this one is cutting this into 2, so this first part here, you just divide by what? By 2. So the first part here, it is 225, which is half of that one. From the reason why I've seen that these are equal, from here to there, 6. From here to there, 6. So the 450 here is for these 2. Have you seen? It is for these 2 there. So what you need to do now is that you've got this one divided by 2, you get 225 meters. So this is a 225 meters. So from here now, what you are going to do is that, okay, this is 225. So this part here, when we get this part, when I get this part, this is what? This is a triangle. Since I'm using distance, so I'm going to use the formula of distance. The formula for distance. So this is a triangle. So I'm going to write it there. I'm going to say distance is equal to half BH. That is the formula. Then distance is this 225. Say 225 is equal to half times the base. What is the base? 6. From here to there it is 6. Times the height from there to there, which is V. The height is V. Have you seen? Where I'm going to say 225 is equal to What is half of 6? It is 3. So 3v. You divide both sides by 3. 3 cancelled. So which means that v is equal to 225 divided by 3. What answer are you getting? You're getting 75. So which means your v is what? Your v is 75. That is your v. The value of v is what? 75. So that's how you calculate the value of v. 75. Have you seen? It is what? It is 75. We move to this other question. I move to the last question. So the last question is, find the distance between the trains during the first 6 seconds. Have you seen? You find the what? You find the distance between the trains during the first 6 seconds. So during the first 6 seconds, you check here. For this one, so for train B, during the first 6 seconds, this one, it covered a distance of, so you have the B, it covered the distance of 225 what? Meters. You know this one. The one we from using. Then we go to A, we find the A. The first 6 seconds it is here. So it is making a what? A trapezium there. Are you able to see a trapezium there? So this trapezium 6 is here, like this. Even there you move, then you go like that. So we are making what? We are making a trapezium there. This is a trapezium. Where this one here, it is A. This one there, it is B. Then the height is this one, like this. So I calculate the distance for this one. Then I subtract. That will be the what? The difference. So the distance. So it's saying find the distance between the trains. So the distance between the trains during the first 5 seconds. So here you are just told to find the what? The distance between. So the distance between the trains. The distance that is between the trains. Have you seen, or rather the difference between the difference in distance between the trains. So I'm going to use the formula for what? Trapezium. Where I'm going to say half like this, A plus B, then H like this. Where I say this is half, then what is your A? Your A, the difference there, the A there. So it is 2. You say 2 plus B. What is your B? You check B. B is what? From there to there, which is 6. So you put what? You put 6 cross. Then what is your height? Height. What is your height? From there to there, which is what? 50. Have you seen? This is your height. 50. So you put your 50 there. Say 50 there. So you can do this. 1 there, it is 25. So here it is 8. 8 times what? 25. What are you getting? 8 times 25. What are you going to get? So you are going to get what? Here the answer will be what? 200 meters. So this is for train what? Train A. So this is train A. Have you seen? So train A covered this distance of 200. But train B, during the first 6 seconds, it covered the difference of what? 225. So since they want you to find the distance between the trains, which is what you're going to do is that the train B, which covered a longer distance, so you're going to say train B for train B minus that one for train what? Train A. So train B is having 225 minus what? 200. So when you calculate there, what answer are you going to get? You're going to get definitely 25 meters. This is the what? This is your answer. So this is the difference between the trains during the first 6 seconds. This is how you need to calculate this. So as you can see, have you seen the marks that these questions were carrying? The first one was carrying 4 marks. The second one was carrying 6 marks. You can't afford to miss these marks. So let's make sure we get all these marks. So we are going to end here. So if you haven't subscribed to this YouTube channel, I'm telling you, I'm your tutor. So I want people to subscribe to my YouTube channel. So let's subscribe to this YouTube channel so that we can learn together. Thank you so much. This is my official YouTube channel. Thank you. So let me give you now the exercise in the group, a question that you are going to practice.